You stand in a modern gym, dripping with sweat. It feels uncomfortable, messy, and slightly embarrassing. You wipe your forehead with a towel and wonder why your body produces so much sweat. But that messy fluid is actually your species' greatest biological superpower. It's the reason you're alive. It's the reason your ancestors conquered every continent. The story of how you got it is written in the DNA of an insect on your body. Episode 5. The Naked Ape. Every other primate on Earth is covered in thick fur. Chimpanzees, gorillas, orangutans, gibbons. All of them are wrapped in dense coats of body hair. You are the exception, the one naked ape in a family of hairy primates. And the reason why is one of the greatest detective stories in evolutionary biology. Rewind the clock 1.2 million years. Our ancestors, Homo erectus, still had body hair. Not as thick as a chimpanzee's, but a visible coat covering most of the body. Being hairy came with problems. Fur is a breeding ground for biting parasites. Ticks, fleas, and lice burrowed into hair follicles and fed on blood. The itch was constant. The infections were worse. But the biggest problem wasn't parasites. It was heat. Our ancestors lived on the African savanna, an open grassland. Midday temperatures regularly exceeded 40 degrees Celsius. Hairy animals cannot run under the midday sun. Their fur traps heat, and their bodies overheat within minutes. This is why lions hunt at dusk and dawn and sleep through the hottest hours. It's why chimpanzees stay in the shaded forest canopy and avoid open ground at noon. Fur is a prison of heat. But our ancestors needed to be active in the heat. They were moving out of the forests and onto the open savanna. Here, large herds of antelope, zebra, and wildebeest grazed under the blazing sun. To access this food, they needed to solve the heat problem. So evolution did something radical. It stripped away our fur. Over hundreds of thousands of years, the genes for dense body hair were switched off. In their place, our ancestors developed something extraordinary. Eccrine sweat glands. Between 2 and 5 million of them covered nearly every square centimeter of the body. Humans can sweat up to 12 liters per day. No other primate comes close. No other land mammal comes close. We are the most efficient evaporative cooling machines in the animal kingdom. When sweat evaporates from bare skin, it carries heat away from the body. This is the same principle as a car radiator or an air conditioning unit. Our entire skin surface is one giant, biological cooling system. And this cooling system unlocked the most devastating hunting strategy in history. Persistence hunting. Imagine the African savanna, high noon. The temperature is 42 degrees. A kudu, a large antelope, stands in the shade of an acacia tree, panting. A group of Homo erectus hunters begin to jog toward it. Not sprint. Jog. The kudu bolts. It is far faster than any human, capable of 70 kilometers per hour. It disappears over the horizon in seconds. The hunters don't stop. They follow the tracks at a steady jog. 5 kilometers per hour. 6. 7. Not fast, just relentless. 20 minutes later, they find the kudu again, resting in the shade, panting heavily. It sees them and bolts again. They follow. Again. And again. This continues for 2 hours. 3 hours. 4 hours. 5 hours. Here's what's happening physiologically. The kudu cannot sweat. Like most mammals, it can only cool itself by panting. But panting requires the animal to stop running. And panting and galloping use the same respiratory muscles. The animal cannot breathe fast enough to cool down at full speed. Every time the kudu sprints, its core body temperature rises. Every time it stops to pant, the hunters appear again. This forces the kudu to run before it has cooled down. The human hunters, meanwhile, are sweating continuously. Their body temperature stays stable at 37 degrees. They are hot, tired, and thirsty, but their cooling system never fails. After 5 hours, the kudu's brain begins to overheat. Its muscles cramp. It staggers. It collapses. It dies of heat stroke without the hunters ever needing to throw a spear. The humans simply walked it to death. This is persistence hunting. It gave Homo sapiens access to the richest food on the savanna. They hunted during the hours when other predators slept in the shade. We didn't need claws. We didn't need fangs. We didn't need venom. We had sweat. And there is a direct line from our sweat glands to our intelligence. The human brain is the most metabolically expensive organ in the body. It accounts for only 2% of body weight, but consumes 20% of our energy. And it generates enormous amounts of heat. A brain running at full capacity raises its temperature by half a degree every 10 minutes. Without constant cooling, the brain would literally cook itself. Our sweat glands kept the brain cool enough to grow. Larger brains required better cooling. Better cooling required less fur. Less fur enabled more sweating. More sweating enabled longer runs. Longer runs provided more protein. More protein fueled larger brains. It was a positive feedback loop that drove human evolution for over 1 million years. But here's the mystery. How do we know when we lost our fur? Hair doesn't fossilize. You can't dig up a skeleton and determine whether it had body hair. The fossil record is silent. So scientists turned to an unlikely witness: lice. In 2004, geneticists published a study using lice DNA as a molecular clock. Here's the logic. Human head lice are direct descendants of chimpanzee lice. When our lineage split from chimpanzees, the lice came with us. As long as our ancestors had full body hair, lice could roam freely. But as body hair disappeared, the lice became stranded. Head lice were trapped on the scalp, which retained dense hair. Pubic lice were trapped in the groin. The two populations were separated by a vast desert of bare skin. Over time, these isolated populations diverged genetically, like animals separated by an ocean. By measuring this DNA divergence, scientists calculated when the split occurred. It happened approximately 1.2 million years ago. That is when we became naked. But the lice had one more secret to reveal. There is a third species, the body louse. Unlike head lice, body lice live in clothing, not hair. Their claws are adapted to grip fibers instead of hair strands. They lay their eggs in the seams of garments. They are a species that cannot exist without clothes. By dating this divergence, scientists calculated when humans first wore clothing. It occurred approximately 170,000 years ago. The origin of fashion, recorded in the DNA of a parasite. This timing makes perfect sense. 170,000 years ago, the Pleistocene Ice Age was intensifying. Global temperatures plummeted, and glaciers advanced across the northern hemisphere. Our naked, sweaty ancestors were now freezing to death. Without fur, Homo sapiens needed artificial fur. We began curing animal hides, stretching them into wearable leather. And then came the breakthrough, the bone needle. A tiny, elegant tool carved from animal bone. It had a hole drilled at one end for threading sinew. It appeared in the record 60,000 years ago, and it changed everything. With the bone needle, our ancestors could sew form-fitting, layered garments. Stitched seams, fitted sleeves, insulated boots. For the first time, a tropical animal could survive in the Arctic. The bone needle is the most important invention in human migration history. Without it, Homo sapiens could never have left Africa. We could not survive the glacial winters of Siberia or enter the Americas. Every coat you wear today is a descendant of that first bone needle. You sit by the fire, combing your hair with a carved bone tool. This bone comb is your souvenir from the naked era. You tie it to your leather wrap, next to the other trophies. 5 souvenirs. 5 stories of survival. You survived the loss of fur. You survived the cold. Your bare skin made you the greatest endurance predator on Earth. No horse, no dog, no wolf can beat a human in a marathon on a hot day. But the sky is turning dark. Not with clouds. With ash. A sleeping mountain is about to wake up. It will push your entire species to the edge of extinction. Find out in the next episode.